Number 4 and 6 as we find lengths within a triangle. That's been given some information about centroids. It tells us that G is a centroid. Remember, a centroid is made up of medians which go from a vertex to the opposite midpoint. So just looking at this median as an example, here's the vertex, here's the opposite midpoint, which tells me that AF and FC are the same, so I can go ahead and mark those. If I wanted to do the same thing for all the other ones, here's a median that goes from this vertex over to the midpoint of the other side, which means those two are the same. Over here, this section from BE to EC are all the same. Okay, so a little bit of information that we have there. We're also given the fact that this one's 12 and this one's 6. That tells us over here that that's 12 because we already said that those two portions are the same. We can't say anything is necessarily equal to 6, but we can make use of the 2/3 rule that we have in dealing with medians. Remember, 2/3 means that the centroid is 2/3 of the way over to that opposite midpoint. So if I split that median into 3 sections, from the vertex to the centroid is going to be 2 of those 3 sections, which means I've got one more section over here. Well, if these 2 sections equal 6, one of those sections must be 3, and that's what I'm left with over here. Okay, so that's a bunch of information I can know, and now when I'm looking to find the length of BF, which goes from here to here, I had to add both these portions. This one's 6, and now this one's another 3, so we can say that that has to equal a total of 9. When I was looking for GE, GE is this segment right here that goes from this point over to this point. GE is a little bit trickier to find. We know that GE is 1/3 of AE, but we really don't know AE at this point yet either.